Good morning, student. Let's start today's class. Okay. In today's class, we are going to discuss about solar cell characteristics. That means, uh, the characteristic which show when the solar cell is irradiated. Irradiate. That means when the sun light is fall on the solar cell, what characteristic of voltage and current, or the what is the relation between voltage and current we can see here. Okay, that means we can draw a, IV characteristic of uh, solar uh, solar cell. Okay, you see, this is the IV characteristic of solar cell. Okay, and this solar cell, this IV characteristic is drawn for two cases. Okay, one is when the solar cell is not irradiated. That means when the solar cell is not shown in the direct sunlight, or the sun ray didn't fall on the solar cell. Okay, and the second case is when it is irradiated. That means when the direct sunlight is fall, or the sunlight is fall on the solar cell. Okay, these two cases we can take consideration uh, when we draw our IV characteristic. Okay, then you see the, when the light is incident on the solar cell. Okay, electron hole pair are created at a constant rate, providing an electric current flow across the junction. Okay, the net current is thus the difference between the normal diode current and the light generated current, which is IPH. Okay, then first consider, let's say, let's first consider the uh, op, you know in solar cell generally referred as a PN junction. Okay, so we consider here the PN junction. Okay, 1 minute. Okay, generally that means the solar cell is a PN junction diode. Okay, when that PN junction diode is exposed to sun radiation, that diode worked as a photodiode, and when it is not exposed to sun radiation, that time that diode is worked as a general purpose diode. Okay, or general diode. Okay, okay. So consider now let's say first we consider when that Pn, this is the Pn. Okay, this P, this N. Okay, when this PN junction diode is open circuit, or there is no connection, or there is no connection of load. Okay, so that when the sun radiation irradiate, the sun radiation fall on that what on that PN junction, we know hole and electron pair are created. Okay, hole and electron pair are created. Okay, pair are created here also. Hole and electron pair are created. Okay, so when and due to this space charge region, in previous classes we have already discussed that due to this space charge region, the from the n region, the hole is migrated, or attracted and migrated towards P. Okay, and due to this space charge region, due to the space charge region, the electron from p side is migrated to the n side. Okay, so here what happened, you see, after migration, after migration, what happened, this is p type, this is n type. After migration, here electrons are deposited, or excess electrons are deposited here. Deficiency of electron, or which is called hole, is deposited. So this is became positive and this is became negative end. Okay, then due to the difference of voltage or difference of potential, one voltage is created. Okay, due to the difference of potential, that means here negative, here positive, that difference of potential created a voltage inside that inside our uh, PN junction or solar cell. Okay, and that voltage is build and build. That means whenever or gradually whenever the sun ray radiate, the electron from the photon from n side is going to p side, and the hole from n side going to p side and deposited here, and the electron from p side to n side and going to n side and deposited here. Okay, so the voltage is increasing gradually. Okay, and the voltage, and at a point that voltage is maximum, or did or didn't increase at that point, or when the maximum number of electron deposited here. Okay, and a sufficient number of hole deposited here, and that electron is repelled when the electron is coming from the p to n, and this electron repelled by the deposited electrons, and also likewise the hole is coming from n to p is repelled by the hole deposited in p side. At that point, what happened, the voltage is not increasing further. Okay, further, so this is our voltage, maximum voltage we can get from PN junction or solar cell. And so in the open circuit we get our V max, which is shortly smaller than our V open circuit voltage. Okay, so here you see this is open circuit voltage VOC. Okay, and this is maximum voltage little bit smaller than the VOC. Okay, similarly, when we consider the PN junction, okay, PN junction, a closed circuit or closed circuit, not closed circuit, a short circuit case. Okay, first of all we consider open circuit, second we consider it is when it is short circuit. Okay, then since it is short circuit, okay, so the 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 here electrons are there, and here holes are there, hole is positively charged. Okay, so when it is connected or short circuited, that hole is going and that electron is going and combine each other. Okay, that hole is going and electron is going and combine each other. Okay, so the amount of electron and the amount of hole here depleted or deposited is gradually decreased. Okay, and at a point when there is no electron here there, and there is no hole here there. Okay, so in that point, what happened, in that point, when the electron from p side to n side going to n side, and n side to p side going p side, that electron combine, okay, combined and diminished. So there is no voltage, there is no charge here, there is no charge here, so there is no charge or potential difference, okay. There is no since there is no charge here and here, there is no difference of potential, so there is no voltage, okay. There is no voltage inside the PN junction, okay. And the electron flow from here to here, okay, that means p side to n side, okay, inside the here. So the current flow in the opposite direction of the electron flow, current flow that direction, this direction current flow, okay, from p to n, okay. So and at that time since there is no voltage and there is no voltage and there is no resistance or load in the circuit, so current is maximum. That you know, V is equal to IR, okay, when and I equal to V by R, when there is no or voltage is 0 and R is 0, okay, or this is minimum and this is minimum, okay. So this is maximum, okay, logically, okay. That means when there is no voltage or at the point when this this is when this is IS short circuit current or maximum current is possible when we short circuit our PN junction, okay. So the characteristic is when the solar cell is exposed to sun, that characteristic going from this to this like this, okay. And when there is no irradiation, that means when the solar cell does not expose to sun, at the time the PN junction behave like a general PN diode, okay, not a photo PN diode. So at that time the behavior is like this, okay. You see this and this is similar, okay, but this is downward, okay, from this, okay, because the reverse bias, okay, since photo radiation photodiode is reverse bias, so that it is shifted downward. And remember that uh, the maximum, this is P max, okay, the maximum power in solar cell is always happened when the cell is reverse bias. That means the current is minus and the voltage is minus, or voltage V max is minus and V I max is also not minus, that means in negative side, okay. So in the fourth quadrant of IV characteristic, this is first, second, third and fourth. The fourth quadrant we get P max, our power maximum efficiency or maximum power of solar cell, okay. And you know, the P max equal to I max and V max, and one factor is there which is called fill factor, okay, and fill factor is P max by VO and into IS, okay. That means P max P max by PO and IS. This is the fill factor. Okay, this is, remember the formula. And the efficiency of solar cell is P max into A into IGB, G beta. Okay, Ig beta is, which is Weber per meter square, is the total solar radiation incident per square meter of solar cell. That means the intensity, the total amount of intensity radiated or radiation fall on the area, fall on the one square meter of area. That means uh, 1 square meter. Okay, this is, let's say, 1 square meter, this is 1 meter, 1 meter. Okay, it, this in between this square meter, how much of maximum uh, uh, sun radiation fall, that intensity is called IGB. Okay, and A is the area of solar cell, total area of solar cell, the meter square. Okay, so so efficiency is this, and in P max you can place this. Okay, so this is this. Remember this formula, this three formula. Okay, remember this three formula. Okay, thank you. Okay, okay, listen. And when there is, I already told you, when there is no irradiation, the PN junction is behave like a general PN junction, and uh, this curve, this curve, okay, this is when not it not the solar radiation not fall on the solar cell. So at that max V max, okay, the current is increasing rapidly. That means the PN junction, the behavior of PN junction. Okay, this, due to this depletion region, or due to this depletion region, the current is not increasing for a or not increasing until a certain voltage, and after the certain voltage, this depletion region break down, and the current is increased rapidly. Okay, this V max, this at this V max, this depletion region break. Okay, so the current is increased rapidly. Okay, thank you.